Hello. I'm sorry I'm late. I couldn't find my phone. I wasn't able to log into a Boiler Key, so I had to go find my phone. Okay, so you should hear me now. Okay, people are entering the meeting. You should be here. Is the desktop look okay? Do you hear me all right? Does everything seem okay?
Yep.
Yeah, we can see your desktop.
Okay, great. Thank you. Okay.
Also, there's some people that I know that are trying to get into the class, but like the course website isn't loading fast or something like that.
The course website?
Yeah, they're trying to get to the website to get the Zoom link.
Oh.
Yeah, I was actually one of those people. I got
You know,
lucky.
the whole website was gone for several hours last night. I don't know if that's a continuing problem, but last night, this website and a whole bunch of other websites on PNW, not the main web page, but the registration, a whole bunch of websites were down for several hours last night. So maybe there's something still not quite right. But I had no trouble loading this page. Let's see. Yeah, these pages are loading. Okay, but there's a lot of people here now, so I think hopefully everybody who needed to, I think everybody's here pretty much. Okay, I think close to everybody is in here. Yeah. If anybody has trouble, they can send me an email. If you know anyone who has trouble, they can send me an email. You can try to figure out if there's something weird going on. Okay. Did I put a link to these in Brightspace? I don't remember if I did. Well, anyway, none of the issues. This note here, starting next week, we're going to not be meeting by Brightspace or not by meeting by Zoom anymore. Okay, so today's Wednesday. When on Monday we'll meet in class. You know, whatever the classroom is, this class has been assigned to. I forgot what it is now. I'll put a little note up there. You have to look at your schedule to remember what room we're actually meeting in. But I think it's in Gite. Okay. But starting on Monday, everybody's supposed to be back in the classroom on campus. Okay, did you guys get an email about that from the university?
Yes.
Yeah,
Yes.
okay. Yeah, I got one yesterday afternoon. And it said that the students would be getting an email about it soon, but they didn't send us a follow-up on that. So I wasn't sure if you've been told or not. Okay, so Monday we'll be meeting. So there won't be when we meet in class, I don't have any way to Zoom from a classroom. So there'll be no Zoom after we start meeting in class. Okay. All right. So okay, now the homework assignment, there's currently this homework assignment's due today. Does anybody have any questions about it? Any questions come up that anybody want to ask right now?
Are we supposed to have a config file inside when we submit it, or is it
No,
just
no,
users?
no. I'll do all that. I'll test your program. So like it says down here, the only thing you need to send me is, where is it? Your filter.c program. Yeah, I'll do all the testing. I'll provide the data, I'll provide the config file. So I'll run a test script and run your program. I'll run a test script similar to the one that's in the homework assignment. You know, the homework assignment comes with a test script, and I'll run a test script like that on your homework assignment. So all you need to send me is filter.c. Okay?
Professor, do we send the zip file or just the actual filter file?
Please send a zip file. It helps a lot. Yeah, please send a zip file. Like in here, it says that to send zip files. You're right. Even if it's only one file, please send a zip file. It makes it a lot easier for me because when I unzip your zip file, I get a folder that I can run your code in. If you just send me your program, then I have to create the folder. So it's real easy for me to automate this when you send a zip file. I unzip it, there's the folder that then I copy the data into and I run your program in that folder. So even if it's one file, it still helps a lot to have it be a zip file because the zip file unzips into its own folder. Okay, and that makes zip files real. That's one of the nice things about zip files in that way. Okay, so even when there's only one file, please make it a zip file. Put it inside of a zip file. Okay. What other questions? Anything? Other questions about the homework?
Hey, Professor.
Mhm.
At the end of your correct test results data file, that text file, well, at the end of each output, each correct output, There is a space as if, someone put the backslash in there.
Uh-huh.
Do you want us to replicate that in our homework as well?
That, I'm not gonna
It's just
worry.
an extra space at the end of each output.
Yeah, okay. Let's see. That's this file here?
Yeah, so yeah, exactly. At the end of 704, you've got a line space there. Yeah.
No,
It's the same for every other time it fully runs the program as well. It's just one last indentation.
this file doesn't have the space at the end, but maybe your output does. See, this file doesn't have,
Oh, no, sorry, not a space. I mean the extra line break at the bottom. Yeah.
well, after, this one here,
Yeah.
yeah, try. I- That's not gonna be the most important thing I look for, but yeah, it's good idea just try to match this thing perfectly. Yeah, if you can match this thing perfectly, that's good. If this line is like, sometimes people end up with a space on that line. Notice my editor here, I can turn on visible spaces, which is really useful. I don't know, if you have a text editor, it's your favorite text editor, learn how to turn on visible spaces in it. It's really useful to be able to turn on a visible indication of where all the space and all the new lines are. Okay, so I can just turn it off and on. So sometimes I'm not going to care a whole lot about like an extra space there or an extra space there. Okay, so try to match this as closely as you can, but I'm not going to be picky about some of those extra spaces. You do need this blank line between the groups. So you're not asking about the blank line between the groups, right?
No. Just that last bit at the end.
Yeah. I don't remember why that's there. I don't remember if I put that there on purpose or if that got there by accident. I honestly don't remember. But that's what my output looks like. So my program did that. So you should be able to get your program to do that. So try for it. But an extra blank line like that is not going to make or break the assignment. It's not going to be the most important. See, like there's a blank line at the end there. Okay, like in my case, I have a blank line at the end.
Mhm.
If you had it like this, it's not going to make a big difference. I'm not going to take off points, but try to make it look like that. Because that's one of the goals of programming is there are situations where these things make a big difference. Like the existence or non-existence of a blank line at the end of that file. I know programs that act differently depending on whether there's a blank line at the end of the file or not a blank line at the end of the file. Some programs treat those as very different cases. So as a programmer, you've got to be able to like match any condition that somebody gives you. It may be tricky. In this case, I'm not going to be picky about it, but it's a good goal to try to match exactly what's here. Okay, so go ahead and try to. But if you have questions, send me an email. Like if you have your source code and you can't quite get it perfect, you can always send me your source code. I might be able to tell you what's missing or what's needed. But blank lines, except for the blank line here between groups. Other than that, the other blank lines I'm probably not going to be real picky about. Okay.
All right, thank you.
Other questions of homework? Let me show you. Let's see.
Do we send it to you in the email or submit it through Bytespace?
Pardon me?
Do we submit it to you on the email or through Brightspace?
The homework assignment should be submitted to Brightspace.
Okie dokie.
Yeah,
Thank
yeah.
you.
So yeah, your final homework assignment. You can send me if you send me your homework if you have a question about it, but submit it to Brightspace when you're done. Okay. I wanted to show. Okay, I'm going to run the filter demo with the input being data. Yeah. Well, I'm going to Oh. Okay. Suppose I have two files. And you open this one, you open this one. How do you tell real quickly if they're the same file or not? How do you how do you tell real quickly if two files are a little bit different or exactly alike? Like, for example, those files are no longer exactly alike. Okay, those files are no longer exactly alike. If you look, like this one has 525 bytes, this one has 519 bytes, but they sure look alike. How would you tell if they're different or not? I have a question. How does anybody, do people, like, what have you been doing if you want to check the output of a file?
Would you want to do Control A to see all the spaces?
Do what?
Control A to see all the spaces.
Oh, okay, that's one way. Now, see, yeah, Control A highlights everything, so you can get a visual sense that there's might be something. Okay, now that's not a bad strategy. Okay, Control A, but you have to check it visually. Like, you have to look carefully at this and see, oh, that line there is different. Like, there's a difference here. See, yeah. So you can do things. But what if the file is so big you can't fit it in one window? What if the file's 10,000 lines long and you want to know if two files were the same or not? What would you do? Now, this is a common problem. Programmers need to check the contents of files all the time and compare them. Like, when you do your homework assignment, you're supposed to have an exact output that looks like this. How do you know if your output looks exactly like that or not? How do I do it when I grade your homework? I use a program. Okay, actually, I don't use that one. Let's see, which is the one I use? Let me show you real quick. There's a program you can get from the internet that does this for you, that checks two files and tells you whether they're the same or not. I'm trying to remember the name of the program I use now. I use it all the time, but I forgot the name of it. Real quick, let me just. Oh. ExamDiff. Ah, that's it, ExamDiff. So let me search for that. Here it is. Very nice program. See, here's a version you don't have to install. Okay, like if I download that, let me just show you real quick how it, just extract it. Okay, when you run this program, it asks you to tell it about where two files are. Okay, so it asks you to tell it where two files are. So here's how I would do this if I was put a shortcut of that into the folder you're working in. Okay, so put a shortcut there. Okay, so there's ExamDiff in this folder. Suppose I want to compare those two files there. I can just start up ExamDiff and ask for I have to find the folder on my desktop. There it is. Okay. That file and that file, then click OK. See? And it'll show me side by side. Now, examdiff shows them as it being equal, but in fact, they have different amounts of spaces. And one of the things you can do with examdiff is you can tell it how to compare files. Like you can tell it you want to compare spaces or not space or skip space. Like default, it actually skips spaces. So when you put extra spaces in a file, examdiff doesn't even, it ignores the extra spaces. But for example, put two little differences in there. See how it tells me where the two differences are? It shows me there's something on this line different from that and something on this line different from that. Okay. And you can use this. This will tell you it highlights. Now it didn't highlight exactly where the difference is. It just said that this line is different from this line and this line is different from this line. Now I know that some of the other lines are also different because they have different numbers of spaces. Right now, you'd have to go in here and change the way examdiff is configured. You can change the configuration of it to tell it to look for spaces, but by default, it doesn't look for spaces. Okay, by default, it ignores extra spaces. But this is how I test your programs. I run your program and then I compare your output with the correct output, and I'll see real quickly whether your program has the correct output or not. And I get in this thing, if the two files are exactly alike, it'll give me a little message saying that they're actually exactly alike. So if I make two copies that are exactly alike, see, here's the pop-up saying the files are exactly identical. So if it gives you a pop-up window saying, they are identical. This is a really great tool. It's free. It's a free program. You can download it, and just, you don't even need to install it. You just have to unzip it and run it you can run it from the unzip file. This is the tool I use to check if your programs. There's actually, let me see if there's another one I use too. Let me show you one other one. This one is this thing called examdiff. And let me show you. There's another one. Now I forgot the name of it. Let me go look it up. But it's worth seeing this stuff because these tools are really useful. So let me find the other one I use, because the other one has some features that examdiff doesn't have. Oh, I don't have a shortcut to it. Well, that's oh, I can't remember the name of the other one I used. There's another one that's very, very good, and now I'm drawing a blank on. And usually I don't even remember the names of this stuff because once I have a shortcut to it, I don't have to remember what its name is. Let me see. I can't remember when was the last time I used it. Oh. No, I don't remember the name of the other one. But the other one has the advantage that it'll show you exactly where in a line a difference is. Remember, I showed you this one just shows you that two lines have a difference, but doesn't highlight exactly where the difference is. The other one, it's not as easy to use as examdiff, but it'll actually show you where in a line the difference is. So a program like this is really useful to have. Yeah, you can have something check real quickly for you whether a file has the output that you're supposed to have or not. So you can compare two files together real quickly this way. Okay, so I recommend that you have a program. Windows doesn't come with a program like this. It actually does, but it's not a very good one. That's this program, WinDiff. WinDiff comes from Microsoft, but it's not as good a program as these other ones are. Okay, so I haven't found that much use for WinDiff, but WinDiff, diffs, people call these when you compare two files, like on GitHub, this is called diffing two files. And Linux comes with a program that does this built in. Okay, and the program in Linux, when it compares two files, it produces a diff file. It produces a difference file. Okay, and these are used all the time in checking in and checking out code into GitHub to find out if the code has been changed or not. Okay, so the programs are usually referred to as diff programs. Yeah, so examdiff, windiff. The one on Linux just is called diff. Okay. Here I switched to Linux. I think diff is on here. Yeah, I can say diff, TEMP, and oh, you can't have spaces in file names. Stupid me. There's a diff file. Yeah. See, there's the command diff telling me line 7 differed, and see these lines differed. Okay, so there's the diff program, and let me show you one other way I do this. Okay, if I use TextPad a lot, so if I open that file in TextPad, and I open that other file in TextPad, I can say tools, compare files, okay, and down here I get the comparison. And if you notice, that comparison is the Linux comparison. TextPad's mimicking Linux because the Linux diff program, see, I use the diff program. The Linux diff program is the standard program for differencing two files. So the TextPad editor, when it does a difference of two files, it gives the output in the format that diff uses. So the output looks just like diff's, almost exactly like diff's output. Looks real similar to diff's output. Okay, so this now you should have a differencing tool built into your text editor. Whatever text editor you use, like Visual Studio Code, it doesn't come with a differencing tool built into it, but you can install a differencing extension to it. So either use an editor with a differencing tool built into it, or add a differencing extension to TextPad, or download a program that does differencing, or if you have, or use the Linux version of differencing. But it's such an important tool. It's, it should be, you should have it at your fingertips. If somebody gives you two files and they claim they're the same, but you have a feeling that they're not the same, but the files are too big to examine character by character, you need a program to do that for you. So you need some sort of diff tool. Okay, so WinDiff, diff, or a good way to do it is just to build it into your editor. TextPad is nice because it actually comes with it built in. Most editors, it's not built in, but it can be added to the editor through some extension. So TextPad makes it nice because TextPad has this compare files tool just built into it. Right? That's one of the TextPad I like a lot because TextPad has all the tools I need built into it. TextPad's a really well-designed, small, simple editor with lots of good tools built into it. But it's not free. It's not a freeware program. Okay. All right. So as the semester goes along, our programs are going to get more and more complicated, and the output from them are going to start sometimes get more complicated. So it's useful to have a way for you. You should have a way to check two files to see if they're the same or not. Okay. Well, any last question about the homework assignment? As we go along the semester, I'll keep trying to point out tools that are useful. Programming is a lot like tool. In fact, the idea that programming is so much like tools, there's even a well-known website called the Software Carpentry Tool website. These are people who help you learn how to use tools, software tools. So they call themselves Software Carpentry. And they run, their stuff is really good, but they run seminars and they have online stuff for teaching you mostly how to use Linux, how to use Linux tools. And lately they've had a lot of emphasis on data science tools. So it's a good place to learn how to use Git, R, IPython, but they call themselves Software Carpentry because what they're teaching is how do you use your tools? Yeah, how do you use the tools of programming? Okay, it's a very interesting group of people. It's all open source stuff. It's all the people who do this are volunteers, and for years now they've been building up these lessons on how to teach things. Notice they even have a data carpentry website. Okay, they have a subset website of this called Data Carpentry that talks about the tools of data science. Okay, very good stuff, really well designed. Unix shell, how to use the shell, how to use Git, how to use Python, how to use R. Okay, basics of using the introductory tool use. But the idea that you should learn tools and build up a repertoire of tools is a real common. It's an old idea in the Unix world. There was a famous book from some years ago. See if I can't remember. No, I'm not kidding. There's a real famous book on Unix called something like I can't remember. Maybe it's Unix Power Tools. Yes. For years, this has been a really famous book, Unix Power Tools. Okay, the tools of Unix and Linux. Okay, a lot of the book's not as popular as it used to be because a lot of the information in it now is available on websites. But for many years, this was one of the main books for learning how to get around a Unix system. And the idea was that all these tools on Linux, programs like diff and all these kind of grep and find and diff and all these tools, this book explained how to use them. So we think of this as tools. You need to learn how to use the tools. The single best important tool is a text editor. Then all the tools that come built into the text editor and all the tools you might need besides your text editor. Okay, so as we go along the semester, that's one of the things I'll keep trying to emphasize is build up your repertoire of using tools and get used to saying, oh, I don't need to do that by hand. There's a tool that'll do that for me. I don't need to look at these two files carefully letter by letter. There's a program that'll do that for me. Okay, all right, now let's we're going to start talk. We can go back to this stuff on C. Okay, so here's the folder with some C programs. Don't need that. Okay, we started this the other day. We're going to just keep looking at examples here, and mostly we're going to look at them using the visualization tool, because the visualizer, the goal of these examples is to help you build a model in your mind of what a C program does. Because the thing I want to emphasize is that you don't know, you can't look at the syntax and know what something does. Excuse me. That equal sign there, remember, meant something different than that equal sign there. That little equation, I'm sorry, this little equation here didn't do the same thing that this equation here did. That line of code, 8, is different than 14. And how to explain the difference is subtle. And the best way to explain the difference is like this thing does, is drawing a picture, okay? The big difference is that x1 and y1 are variables that hold a value, and x2 and y2 are variables that hold a pointer, okay? So this set copies the value from x1 into y1. This copies the pointer from x2 into y2. Okay, probably the best way to think about that is in terms of a picture, okay? And pictures can help you really understand code. But the thing is, the visualizer only draws simple programs. When you're writing hundreds of lines of code, you can't turn to the visualizer and get a picture. So you have to start building up your own mental picture of what this code does, because we're going to start doing more and more tricky stuff. And it's important to build up a mental picture of how a program runs, especially a C program. Both C and Java are important, but especially in this case, it's going to be C programs. So these examples, the goal of them is to help you build up a sense of what these programs look like while they're running. Okay. Now I can open the program in an editor. I can compile it in the editor. Okay. It's got a lot of warnings because it's doing kind of funny things. So it's got a lot of warnings, and I can run it in the editor, but the output doesn't do me much good. The real purpose of this example is to run it in the visualizer. Okay. So I'm going to take this code and copy it into the visualizer. So that's the C tutor. Okay. The visualizer in this case is called the C tutor. Okay. So I'm going to take my code and paste it into there. Okay. Okay. Now, this program was working with arrays. So this was the example called working with arrays. Okay. Now, if you look in this folder, there's working with arrays, working with strings, working with struts and strings, working with struts, strings, and pointers. So we want to build up these ideas. How does C handle arrays? How does C handle strings? How does C handle struts? In the Java language, there's not a lot of difference between arrays, strings, and objects. But in C, it turns out there's subtle difference between arrays, strings, and struts. And we want to get a feel for how these guys act differently in the language. Okay, so let's start with arrays. Okay. Okay, so here's a variable that is an array. Okay. Now, if this was Java, you would say that something is an array by putting the brackets on the type. So that would say this is an integer array. C doesn't work that way. In C, you say that this is an integer array. Now, right away, you should think that that's really flaky. The way you read this is from left to, you don't read this from left to right. You don't have an integer called nums1 that's an array. That doesn't make sense to have an integer as an array. What you have is nums1 is an integer array. We'll see as we go along that this idea of reading left, right is a pattern that C uses a lot. When you declare something in C, you tend to read it not from left to right. You start at the variable name, and then you go left, right. Then we'll see sometimes you'll have to go left, right, because we'll see that there's sometimes you get things that are pretty complicated. So you have to go left, right, left, right. So this is an integer array. Now, here's why it matters. Let me open another tab to the C tutor. int x, y, star z, okay? As opposed to int x2, int y2 array, int star z2. Okay. So x is what? An integer. And you don't go to the right because you stop there. Y is an integer array. Z is a pointer to an integer. Notice that Z is read weirdly, left, left. Z is a pointer to an integer. Notice how the int was used on all three of these declarations, but they're declaring three different kinds of things. This is an integer, this is an array, this is a pointer. Now, some people tell you shouldn't write C like this. You should write it like this. Put everything on its own line. So now x2 is an int, y2 is an array of int, and z is a pointer to int. Okay, now if I visualize this, whoop, what did I do wrong here? Oh, I didn't tell it how big an array. I have to tell it array of size 5, say. And same here. Where this visualizer is getting slower and slower and slower. Okay, and hit all my variables don't show up here because I didn't put any values in them. The visualizer tries to optimize everything. So I didn't see my variables because I didn't put values in them. So let me go ahead and put a value in each of these. Okay, x is an int, y is an array, z is a pointer. Yeah, x is an int, x2 is an int, y2 is an array, z2 is a pointer. C has this funny syntax that you put the type here, but then that type carries along all the way to the end of the line until you get to a semicolon. Then that type acts on these variables. So x is an int, y is an int array, z is an int pointer. Okay, so C, you read C in kind of funny ways, and it takes a little bit of getting used to sometimes. Okay, so here's this. Okay, so now a good rule is to not do this. A good rule is to not do that kind of thing. I'm declaring three different variables on the same line. A lot of C programmers do that. A good rule in C is don't do that because it can get really confusing. You can get really messed up when you do this kind of thing. Okay, like a real common mistake that people make in C is to do this. I want an integer pointer, and I want three of them. I'm going to call them U, V, and W. Okay, so I have three integer pointers, or do I?
No, you only have one pointer in U and the other two.
Yeah, only U is the pointer because this star really is over here on U, and V is just an integer and W is just an integer. Okay, that's why you don't put the bracket over here. See, in Java, that would be three arrays. See, in Java, that would be three integer arrays, U, V, and W. In C, I think that's a syntax error. Yeah, see, it doesn't even compile. In here, you have to say U is an integer array, V is an integer array. And if you don't put anything on W, then W is just an integer, okay? But where that gets, the array one's not so confusing. The one that trips people up is the pointer one. It's real easy to think that that's three pointers, U, V, and W, but it's only one pointer. And then what C programmers do is they move that star over to here. And then if you want, now this, for example, is U is an integer pointer, V is an integer, and W is an integer pointer. Or if I want, I could put there. Now, U is an integer pointer, V is an integer, and W is an integer array. Okay, so you have to get a little bit used to the way you read and write C. Don't put multiple variables on one line. It's a bad strategy in C. It can easily lead to confusion. Okay, so it's better to do things like this: one variable per line. Okay, all right. So here's a variable that's an array. Here is the array values. Okay, so I can initialize the array. Notice I don't need to say how big the array is here because this tells it how big it is. If I don't have an initializer here, like I did over here, I have to say, oh, this is how big the array is. So if you don't initialize the array, you have to say how big it is. If you do initialize the array, then you don't have to say how big it is. Now, let me show you over here a real quirky thing. I'll do it down here. Now, how big is W? It's got 5 elements in it. How big is W now?
10 elements, but the other ones aren't filled.
Yeah, exactly. That's what it seems like it might be contradictory. What it's doing is W has 10 elements, but only 5 of them get initialized. The other ones aren't going to get initialized. So you can do quirky things. You can't do anything like this in Java, but you can do very quirky things. Oh. And the visualizer showed it as size 5. I think that might be a mistake in the visualizer. Okay. Yeah, I'm not sure what the visualizer was doing there, but it should be a size 10, but only have this many things initialized. But the visualizer is showing it size 5. Okay. Okay. Let's try something. Let's try putting something in W9. It does, see, it ran, but it didn't show anything. Sometimes the visualizer shows incorrect things. Yeah, sometimes the visualizer doesn't always do the right thing. Okay, I thought it handled this one correctly. We'll see later on. My memory is that drew that was, I've done that before. My memory is that would draw that correctly. Okay, but it looks like it's drawing it incorrectly. Okay, so over here, back to here, we've got this thing here that is an array of size. This is an array of size 5 because it's not declared in here how big it is, so it gets initialized to that size. Okay, now here's a function that takes in integer. It takes in array parameters. Okay, this is one of the things we want to figure out. One of the things that's tricky about arrays is how they interact with functions. Okay, so this function takes in a parameter n1 that's an array. It says here it's an array of size 5, and we'll see that that 5 in this case is ignored. Okay, like over here, it looked like this 10 got ignored. Sometimes that number is ignored and sometimes it isn't. Here, that 5 is ignored. Okay, then there's a parameter s1 that's an int, and a parameter n2 that looks like an integer of size 5, but this 5 gets ignored. And then there's an integer s. Now what this is supposed to be is, this is an array, and this is the size of that array. This is an array, and this is the size of the array. Arrays in C don't know how big they are. So when you pass an array to a function, you have to tell the function how big the array is. Now that's why this guy gets ignored. The function does not know how big this array is. The function needs a parameter to tell it how big the array is. The function will actually ignore that 5. Okay, we'll see how it does it. Okay, but it ignores that 5 and ignores that 5. In fact, the size of the array needs to be in a separate parameter. Okay, it says over here on the comment, the 5s are ignored. Okay, now down here, oh, this array up here is a global array. See, it's not inside any function. That's a global array. Down here are 2 local arrays. Okay, now here's an array. I don't say how big it is here, but then it's initialized, okay, with 5 numbers. Here I say there's an array, and notice that here I put a 5, and here there's only 4 numbers. So we'll see what happens there. But it's a size 5 array, but there's only 4 numbers over here, okay? Then I'm going to call F with this array of size 5 and this array of size 4, okay? Now, here, I'm going to call the function again. This is a real strange little piece of syntax here. That's an array literal. This is an array value that's in that variable. So it's got a name. This array has the name nums2, and this array has the name nums3. This array is an anonymous literal array. The array holds 5, 4, 3, 2, 1. That is an array. Actually, it's a pointer to an array, okay? And it's never given a name. So that array is just created on the fly, and then the function gets a pointer to it. And the size of that array is 5, and then there's that other, then there's the global array up here, passed as another parameter, okay? Now, here's an array that's in the heap. These arrays are all in the stack. See, in Java, all arrays are in the heap, but in C, if you declare an array like this, it's actually in your stack. If you made this array 1 million items, it probably wouldn't fit in the stack and your program would crash. The stack is not as big as the heap, so you gotta be careful in C not to put huge arrays in the stack. Now, this is a little array, but see, this is in the stack, not in the heap. This is in the heap, okay? But arrays in the heap can't be initialized. Arrays in the stack can be initialized. Arrays in the heap cannot be initialized. So that's an empty array. Then this for loop gives it values. We'll watch this happen. Now, watching this stuff happen is going to help a lot, but there's a lot going on here. This is the quirkiness of the C language. Every one of these lines is actually doing something pretty complicated, okay? So this gives me an array in the heap, but you cannot initialize C arrays in the heap. When you declare them, you have to initialize them after they've been declared, okay? Okay, and then I'm just going to call this function a bunch of times, different ways, okay? So let's run this program and watch it behave. Okay, now the program hasn't actually started yet, but it started, but it's at this line 28. Notice that the global array is there in memory already. None of the other arrays are initialized yet. So everything else, all the local variables are uninitialized because I'm still at the beginning. I'm at the first line of main. That's where the visualizer stops you, at the first line of main. But before main starts, the global variables get initialized. So I have that array there all fixed up, okay? Now I start stepping through, and now I'm going to initialize this array, okay? Okay, so that array got its initial values. Now I'm going to initialize the next array. Okay, so that array got its values, okay? Now I'm going to call a function, okay? So this line calls the function f. Now, when you call a function, you have to create, now this is the main function. These are the local variables of the main function. When I call f, I'm going to get another blue box that holds the local variables of the f function. Okay, see, there's the blue box that holds the local variables of the f function. The main function is no longer the active function. So this is the stack. The stack is growing down. Okay, the stack variables of f are above. Actually, this shows it below. The stack variables of f are below the stack variables of main. Okay, so now we're in the f function. Okay, now these are variables of f. So f starts off with those variables. See, it's got its parameters. Okay, now the way the visualizer shows it, those parameters haven't been initialized yet. See, it shows me at line 9, and see, if I click to line 10, it actually initializes the parameters. Now the result variable hasn't been declared yet. the result variable is not going to get declared till, where is it? Line 13. See, line 13 is where results going to, so right now results still undeclared. So it shows up as a question mark. It's not, it's uninitialized still. Okay. Now notice that I actually haven't executed any, the way the visualizer does this is when you call a function, it shows you at the brace of the function. The function has got its parameters, but according to the visualizer, they haven't been, the values haven't been passed to them yet. So when you click one step, you still haven't executed. Well, oh, here, yeah. So now the things haven't been initialized. It skipped over this line here. Huh. The visualizer is going to do this opening brace, which initializes this thing. It should have gone from line 9, from not line 9 to line 10, but I'm not really sure what they did there. Okay. Yeah, okay. Okay. Let's look real carefully at these. See, now we got the variables. What? It's showing N1 is uninitialized. And I'm not sure what the visualizer is doing at this point. We passed it. A pointer to nums2. We passed it a pointer to this guy. See, the first parameter was a pointer to nums2. That was this one. But it's pointing to the global one. Let me restart this. Okay. The first time we call this function, we pass it this array here, which is this one here, and this array here, which is this one here. So it's these two local arrays. So we're calling this function with these two local arrays. This one has size 5, and this one has size 4. Okay, let's see. Okay, there's the two arrays. Okay, now we're going to call this function. We're going to pass it a pointer to this one and to this one. There. Okay, that looks right. I don't know what happened before, where I was. Okay, now it looks right. Okay, there's the 2 pointers to those 2 arrays. So we're in the function f. It's got a pointer to that array. Now notice that arrays pass as pointers with functions. Okay, it did not copy this array into here or copy this array into here. We'll see that with struts, you copy the struts. When you pass a strut to a function, the strut will be copied just like an int. Now notice that the integer got copied. Okay, so for example, this 5 got copied to there. And this 4 got copied to there. Integers get copied. Struts get copied. Arrays are pointers. The fancy word in C is we say that that this array degrades to a pointer. nums2 is this array. Okay, but when you call the function, nums2 all of a sudden doesn't become that array. nums2 becomes a pointer to the array. Okay, so up here in the declaration of the function, this guy is not really an array, it's really a pointer to an array. Okay, even though I used a declaration that makes it look like it's an array. That's why the 5 gets ignored, because this thing is not really an array. This is one of the quirkiest things about C. This guy is not an array, it's a pointer to an array. Okay, and in fact, I can even write it that way and it'll mean the same thing as this. Okay, so I could write it this way and say, well, n1 is an array, or I could write it and say n1 is a pointer. In both cases, n1 is a pointer. Okay, so the people in C world say that array parameters degrade to pointer parameters. Okay, so the function, see, n1 is no longer, see down here, it's not called an array, it's called a pointer. Even though I declared n1 as an array, it degraded to a pointer. Okay, degraded to a pointer. Same with n2. I declared n2 as an array parameter, but it's not really an array parameter. It degrades to a pointer. And this can be confusing as heck. It's one of the, I mean, after you've been programming in C, and C++ does the same thing. So you probably saw this in your C++ class, though it may be a while since you saw it, and it may not have been emphasized too much in the C++ class. But in C++, you tend to use more objects than arrays. But in C, we don't have objects. So we're going to use arrays a lot, and we're going to use arrays and struts, but arrays and struts don't work the same way. Arrays degrade to pointers, struts get copied. Okay, so now I'm in the function, okay, and I have these 2 pointers to the arrays, and then this thing tells me how big that array is. So it tells me how many things are, see, this thing just points to the beginning of the array. So this pointer has no idea how long that array is. That's why I need this number here to say that this thing points at an array and there's only 5 numbers after it. And this thing points at an array and this thing tells me there's only 4 numbers after it. That's why arrays in C don't know how big they are, because they're just a pointer to the beginning of the array, and there's nothing to tell you how far the array goes. So you need another number to say how much stuff there is in the array. Okay. Now what this thing does is it checks to see if those 2 arrays have the same size. Okay, so this is asking, is the size of this array the same as the size of the other array? And that's going to be false, so I'm going to skip to the next line. The visualizer just did something really weird.
Hey, Professor, do you think it's the, what's it called, the online compiler's known limitations? Because
Say
it says
again?
up in the top of the what's it called compiler, it says C known limitations. Do you think it's that? Like, it's one of the limitations of the
No,
online
I don't
compiler?
think so. Because I've run this program, I've run this example in the visualizer many times before. I've used it before. Let me start it again. Okay, now we jump to F. Okay. Okay, here's F. We're at line 9, so F's uninitialized. Now F initialized. See, we went from line 9 to line 10. We're still not having, notice we've still only just entered the function. No line of the function has been executed yet. But the difference between line 9 and line 10 was at line 9, the variables were uninitialized. At line 10, the parameters are initialized. Okay, so if I step back, see at line 9, the parameters are there, but they're not shown as initialized. Okay, at line 10, the parameters are shown as initialized. Okay, now S1 and S2 are not equal. So S1 and S2 are not equal. So this is a oh. If they're not equal, return 0. Yeah, they're not. So I should return. And now it's acting right. So I should return. Okay. Now I'm going to call it again. The other time something was going fishy. It wasn't doing the right thing. I was clicking next and it wasn't doing what it was supposed to do. But it was supposed to, this function was going to, the first thing it does is it checks if these two arrays have the same length. If they don't have the same length, it returns. Okay. If they do have the same length, it checks to see if they have the same values in them. So it's really, this function's comparing these two arrays to see if they're equal or not. Okay. So the functions, it's not an important function. It's just meant to just show different ways of manipulating arrays. But what it's really doing is checking is if this array is equal to this array. So it first checks if they have the same length. If they don't have the same length, it returns. If they do have the same length, it steps through the arrays and checks to see if they have the same value everywhere. Okay. If they have if they're different someplace, then they're going to it's going to set them equal there and then jump out. So what it'll do is if the two arrays have a difference somewhere, it'll make them agree where there was a difference. So it'll set them equal where they were not equal. Okay, so it'll do it'll look for places where it'll look for the first place where the arrays differ and set them equal. The first place where the arrays are different, they get set equal there and it breaks. Okay, so the function checks to see if the arrays have the same length, and if they do have the same length, it looks for the first place where they differ and it sets them equal at that place. Okay, it's kind of it's meant to just be busy work to just see how C handles arrays. Okay, right now. Okay, so now this one took pointers to that array and that one. We're going to call F again. Now it's going to be given this anonymous array and this guy that's the global array. Okay, so this time it was two local arrays. This time it's an anonymous array and a global array. So it's okay. There's the first call to F. Okay, it's going to return. Okay. Okay. Now notice the blue box for F went away because F returned. Now we're going to call F a second time. So here's the second call to F. Okay. Now we're at line 9. F hasn't been initialized yet. Line 10 initializes it. Okay. And we're in this case where this guy is an anonymous array and the visualizer doesn't know how to handle it. So that's where this guy came from. This guy came from the visualizer actually not knowing how to handle this funny anonymous array. Okay. So we're seeing a place now where the visualizer doesn't know what to do with this funny little piece of syntax. Okay. So now up here, notice that 5 and 5 agree. So this is going to be false. So I'm going to go down here to here. Now I'm going to step through the arrays. Now, one of the arrays is this global array. Unfortunately, we don't see the other array. Okay. We're going to step through the arrays. And right now, the arrays weren't the same at the first slot. Well, no, they were. The first slot this was a 5 and this one's a 5. Oh, yeah, the visualizer had trouble with that, had trouble with this guy here. It didn't do this guy properly. Okay, that should have gone to the second element here because they agreed on their first, well, this is 5, 4, 3, 2, 1. Oh, they agreed everywhere, so it should have stepped through the whole array. Okay, because this function is looking for where two arrays differ. These guys were the same, so it should have stepped through them, but it didn't. Okay, okay, the visualizer probably didn't know how to find this array. Okay, let's look at the third example. Okay, now we're going to do the array that's in the heap. So this malloc space in the heap. See, now the array is out here in the heap. Okay, this array of size. See, I told it 10 integers. Now, the way malloc works is malloc takes a number that says how many bytes to allocate. Malloc doesn't allocate integers or doubles. It only can allocate bytes. So you have to know, if I want 10 ints, I have to know how many bytes are in an int. Now, usually an int has 4 bytes, but you don't know that for sure. So you're not supposed to just say 4 times 10. You're supposed to call the function size of, which asks how many bytes are in an int. Okay, this is the way you're supposed to write this in C. You're supposed to, you're pretty positive that an int has 4 bytes. In almost every computer around these days, an integer has 4 bytes and a double has 8 bytes. Okay, but you're not supposed to assume that. Okay, so you're supposed to call the size of function that tells it's going to return 4. So 4 times 10 is 40. So this is actually 40 bytes, but the visualizer shows it as 10 ints. Okay, but in memory, it's actually allocating 40 bytes. Then I have to say that those are actually pointers to int. So that's why the visualizer knows to draw these as ints, because the visualizer sees that after I allocate 40 bytes, I want to treat them as integers. So I say that this is a pointer to integers, okay? And then num4s is a pointer to integers, okay? If I don't put this a cast here, I'll get a compiler warning. This tells the Java language that I'm pointing to ints, but you should make the return, you should take the return value from malloc and cast it to a pointer, make this agree with this. So you should make those two agree. If you drop this, it will still work properly, but you'll get a compiler warning. But this is what really determines what's at the end of this pointer. This thing is a pointer to integers. So what's over here is integer, 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 integer. So that's determined by this. This is nice to put in there, but not absolutely required. Okay. Now it's uninitialized because malloc just gives me 40 bytes. So there's really nothing in those bytes. So now I have to step through code and give them values. Whenever you allocate an array using malloc, unfortunately, you have to put the values in it after you've allocated it. Okay, so now I've got an array with the numbers 1 through 10 in it. Okay. Now I'm gonna, now this, okay, now I'm gonna call this function with the parameters num1, which is this global one, and num4, which is this heap one, but I'm only going to use 5 slots of this guy. He's got 10 slots, but I'm only going to use 5 of them. So I'm going to call this function and say, use all 5 slots of this array, but this array, it actually has 10 slots, but the function is only going to be told to use 5 of them. Okay. And so then I'll jump into the function f. So here's the stack frame for f. Right now, the variables haven't been initialized yet. When I skip to the next line, everything gets initialized. N1 points to this global array. N2 points to this array in the heap. N1 has size 5. N2 actually has size 10, but the function doesn't know it. The function just says it can only access the first 5 elements. So the function is only going to use the first 5 slots in that array. Okay. Now, what the function does is it checks to see if the arrays have the same size. Now, the arrays don't have the same size, but the function thinks they do. So it's going to skip over that line because it was told that these two have the same size, even though this, remember, arrays in C don't ever really know how big they are. You have a number that goes along with the array that pretends to be the size of the array. In this case, that number is smaller than the true size of the array. Now the function is going to step through the arrays and look for places where they differ. Okay, so it's going to start stepping through the arrays. Okay, now they differ in the first slot. So it's now going to copy this value over. Let's see, it's going to copy this value over to here. See, it copied that 5 over to there, and now it's going to return. Okay. Now it's going to call those, it's going to call the same function again. Okay. Now it's going to compare these and it's going to see they differ in the second slot. And it's going to copy 2 over to there. So that's going to see now, so it's got 2 pointers to 2 arrays. They're the same size, at least it thinks they're the same size. Okay, now it's going to start stepping through the array. Okay, it's going to see that in the first slot that they're the same. Okay, now it's going to see I is 1. So now I'm going to look in the second slot. It's now going to look in the second slot of the arrays and see that they are different. The 0 here is not the same as the 2 here. So now it's going to copy the 2. It's going to copy this 0 over to 2. See, it copied that 0 over. So now the 2 arrays agree in the first 2 slots. Now it's going to return. It's just going to keep doing that. As I call this function, what this is going to do is you call the function several times. It's just going to make this array. It's going to make this guy equal to that guy. Every time you call the function, it'll find the first slot where they differ and copy them. Okay, so we've seen a bunch of examples here of a function that takes array parameters, but the function doesn't really take array parameters. It takes pointers to arrays. Okay, so that's now real quick, let's look at the example with struts. So I think we have a couple minutes. We'll switch from the working with arrays to working with struts, and then you'll see that something real subtle changes. So here's the struts example. The function's real similar, but instead of using an array, it does almost the same kind of thing, but using a strut where it would have been using an array. So, okay. Here's what the strut looks like. It holds an int, a double, and a char. Here's a global strut. Just like if I had a global array, now we have a global strut. Here's a function that takes in strut 1 and strut 2. Now, struts know how big they are. Every strut knows what its size is. So struts don't need some number, like arrays needed a number to say how big they are. If you give a function an array, you have to tell the function how big the array is. And when you give a function an array, it doesn't get a copy of the array, it gets a pointer to the array. With struts, when you give a function a strut, it gets a copy of it and it knows how big it is. Okay, so this function takes in 2 struts and it does a little manipulating. This function does something different. Now down here, here's a strut, then we'll call the function. So let's real quick, let's just watch what happens. Okay, there's the global strut, it's initialized. The function hasn't started yet, but the global variable is initialized. When I start main, I'll have to initialize the struts as I go along. Okay, so now line 49 is going to initialize that strut. Line 50 is going to initialize the next strut. Notice that the strut sits in the stack. It's not sitting over here in the heap. Okay, it sits in the stack. Now, next step is real important. Okay, we got just a second and we'll do the next step. We're going to call the function f. That gives us a new blue box. That's the stack frame for f. This thing will get copied into that new box, and this thing will get copied into that box. So this strut is going to get this strut here and this strut here are going to be copied to f. Okay, so there's the copies. Not pointers like with arrays, but actual copies. If this strut had 1,000,000 bytes in it, this would have copied 1,000,000 bytes. If this strut had 1,000,000,000 bytes in it, this would have copied 1,000,000,000 bytes. And it's not unusual for a strut to have 1,000,000 bytes in it. You have to be real careful about this. If you don't want to copy the strut, then you have to say pass a pointer, but you have to say that explicitly. But so struts by default are copied. Arrays by default are pointed at. How does Java do it? Can anybody answer that? How does Java do it?
Doesn't it make it a pointer?
Yeah, Java always uses pointers. They call them references though. So when you pass a function an array, you get a reference to the array. When you pass a function a strut or a class, an object, you get a reference, a pointer to it. So Java acts like C does with arrays. It always uses pointers. C uses pointers for arrays and copies for struts. That's one of the biggest differences between C and C++ and the Java language. The C and C++ language default to copies for struts, pointers for arrays, copies for struts. Java chose to use pointers for everything. So for both struts and, except they don't call them struts, they call them objects in Java. But this would be an object. And objects are never copied. Objects are always pointed at. And you can never have an object in the stack in Java. You can never have an object sitting in the stack like this. You can only have pointers to objects in the heap. Okay, so we'll finish this example on Monday, but as this code goes along, it's going to put an object in the heap. Instead of the object being in the stack, that's where it'll put an object in the heap. But if the object's in the heap, then you have to point at it. So then it's acting more like Java. So we'll get used to these differences between C and Java. By looking at these examples, we'll see these subtle differences. When we start writing more code using the Windows operating system, we'll see that these ideas pop up over and over and over again. Right now, it looks like abstract stuff. It just looks like I'm just talking about a language with no real reason why I would want to care about it. But when we start calling Windows functions and have them do things for us, when we call these Windows functions, we have to be really careful about our arrays and our struts and when they're copied and when they're pointed at. And we have to be very careful about this stuff. It gets kind of tricky. So we're doing these examples to try to build up a sense of how the C language differs in when it copies, when it uses pointers. Okay. So if you have questions about the homework, the homework's doing it this today. If you have questions about the homework, send me emails and we'll go ahead and quit there. And we'll pick up on, we'll meet in class on Wednesday. I think we're in Guyte. I can't remember what room number. I think we're in the room in Guyte. But we'll meet in class on Monday, and we'll pick up in this example in class. Okay. Any last question?
Professor,
Yeah?
when is your office hours today?
Pardon me?
When are your office hours today?
Well, I don't actually have office hours today. I have another class this afternoon. I have a little bit of time between classes, but I have another class at 3. So today I have 2 classes in the afternoon. But
what? Go on.
If you have a question, you can send me an email and see if if I'm available for an office hour. Just send me an email. But like I say, I have a class in the afternoon, so I don't have scheduled office hours because I have to get ready for class. But if you have a question, you can send me an email, or you can send me a Zoom link. If you want me to talk with you for a few minutes, send me a Zoom link.
Yeah, definitely. I would do that. I'll send you an email.
Yeah, send me a Zoom link and an email, and we can talk real quickly for a while. Okay, but I don't have office hours because like I say, I have 2 classes almost back to back. I have the next class around 3. Okay, so any other question? Okay, so I'm going to stop the sharing, and we'll meet in class on Monday. Have a nice weekend. Bye-bye.
Take care, Professor.